Good evening, sir.
Yeah, good evening.
This
Yeah.
is Kavya from Usmania University.
Okay.
So the first I'll show the question. Sir, actually, I don't have idea about this tolerance stack up analysis,
Okay.
but regarding the figure, have seen that to find the tolerance of the red arrow line.
Yeah.
So what I have done was I have taken the total maximum. It was mentioned in the parallel dimensioning form. So what I have done was the maximum 36 plus or minus 0.5. That is the total length of the object, what which we
Mm-hmm.
have taken.
Mm-hmm.
So what I have done is the upper limit of this 36 plus or minus 0.5 for that
Mm-hmm.
one, and I have subtracted the value of 10 plus or minus 0.5, that LMC value, and I
Okay.
have founded the upper limit of the red arrowed part. I have
Okay.
mentioned here, so.
Okay. How much is
And
the
the
value?
minimum length is the I have taken the lower limit of the full part
Ah, okay.
and subtracted by the maximum limit of the that smaller part, initial part,
Mm. Ah, okay.
and I have got these
Oh,
values, sir,
good, good.
27 units
So,
and 25.
really, it's good actually. You done in that way, but again, it came actually good. Answer also came correctly.
But afterwards, but today when I have seen what actually it was,
It
because
is
we have
like
no idea, it
today.
was
Today
like
have
different.
yeah, yeah. It is like baseline method, and another one is the chain method. Okay. So
Yes, sir.
the first one you have to basically go with the baseline method. The next one is chain line method. But how you?
Chain dimensioning.
Yeah, but what you got, the answer is correct. But yeah, but the approach is also quite different. But again, you got the correct answer. uh,
Okay.
okay, good.
Actually, I have used the general methods.
Okay, yeah, yeah, even that is also a correct way. But again, you would have seen the baseline method where you have to go with the left, and then in the case of chain dimensioning, you have to go with the individual one.
Okay, sir, and the second one,
Yeah.
question is chain time. Here, I have added all these 6 plus or minus 0.5, 10 plus or minus 0.5, and 10 plus or minus 0. These three parts for the maximum limit, I have added the upper limits, and
Mhm.
for the lower limit of the complete part, I have taken the lower limits.
Mm.
And that's how I got the tolerance of the red arrowed parts for the second one.
Okay. So you have taken the average, 27.5. Okay, so 27.5 plus
Average, just adding and
deriving a 2.
yes, sir.
27.5 plus
Adding of
24
the
point.
upper limit.
Okay, 27.5 plus 20.
27.5, 24.5.
Divided by
Upper
2.
limit and lower limit.
Same thing you did for the previous case also.
Yes, sir, same thing.
Uh, can
So
you go up?
here
Can you
it,
go up? Can you go up?
yes, sir.
Yes, I'm also trying to find a new method. I'm learning from you. It's quite interesting.
I think
Uh,
now you can see both the
36.6 plus 0.5. Okay, so your maximum minus minimum. Okay, uh, so minimum of minus 10.10. So you have taken the maximum limit. Okay. Okay, on what
mm,
basis you have taken the upper limit and the lower dimension, the first one, maximum length? Uh,
yes, sir.
on what basis you have taken
So
36?
once I can I go to the question,
Yeah, you go to the question.
I'll explain over there.
36. Okay, so this is 36 and 10 is the lower. Okay, okay,
Yes, sir.
okay. So,
Actually, that red line part will be the 36 is the complete length of the component, right, sir?
okay, okay.
So to get the maximum value of the red one, we need to get the subtract the smaller limit of the initial part.
Mm-hmm, mm-hmm,
So what I've done is 36 plus 0.5 minus 10 minus 0.5.
mm-hmm,
So that I could get the maximum length of the red
mm-hmm,
arrowed part.
mm-hmm.
That's what I have done. So
Okay, okay. Oh, it's quite interesting. Okay. So go with the third question.
Yeah.
So you two are all final year or third year?
I'm final year, sir, and my teammate is passed out. Oh, she's a grad.
Ah, okay. So
Mm.
you are senior. Okay.
Yes, sir.
So can you enlarge your screen? Actually, it is not visible.
Yes, sir. Now it's
Still, can you enlarge? Yes. Yeah.
mm,
What is it? Okay. This is step by step approach. Okay. Can you explain
mm.
this?
So here what we have done is whatever the component represent that those things we have explained, sir, in the step by step process.
Hmm?
And if initially what here in the step one we explained about we have taken three datums, right, sir? A, B, and C.
Hmm.
How we selected those three is we mentioned here as based on the 3-2-1 principle.
Okay. Okay. Good, good. Okay.
On that basis, those three sites are selected as A, B, C datums.
Hmm.
That was the initial thing we have mentioned.
Hmm.
And later, what in the component, what we mentioned, the basic dimensions of uh, what is the length of each side, and
Okay.
other
Okay.
features like what is the position of each holes where they were placed, those things.
Hmm.
And next day, we mention
So
this
what is
datum
this three?
features.
What is this 3-2-1 principle is all about?
A 3-2-1 principle, actually, my teammate will explain, sir, about the 3-2-1 principle.
3 to 1 principle, it's basically used to constrain a given body. For a given body, when we have 6 degrees of freedom, then we take three separate planes. In the first plane, it is fixed in 3 points. In the second plane, it is second perpendicular plane to the first one is fixed in 2 points, and the third plane is fixed in 1 point. So that totally the body is completely constrained. Here, when we want to establish datum references, also it's the same thing that we want to use, so that the component is constrained according to its conditions. That only we try to say in the datum selection parameters.
Okay.
Shall I continue, sir?
Yeah.
And here the what are the datum features are there in the component we mentioned, sir, like the initial first thing, position tolerance,
Okay.
and
Okay.
M indicates what all
Okay. So
this. Should
what is the surface profile tolerance? They given point A. Okay. With respect
zero
to
point 0.8.
A and C. Okay.
Mm,
Position tolerance, okay, perpendicularity. Okay. Okay. You explain this.
yes, sir.
So
And
there is a question for to find out the position tolerance at LMC. Okay. You are written. Okay. Okay. You explain the step, then you can go with that answer.
next, just we mentioned just it specifies like fits. What is the type of fit? Those can also be explained through the component we have mentioned. So that's all.
Okay. So here is it coming under which category? Is it a interference fit or a tolerance like
Clear.
perfect one or which one it comes under? Is it interference fit or uh,
Okay. So once can I go to the question?
no, I'm asking you. Okay, you can check.
Means once to check.
Yeah, tolerance fit is also there. You just
This is
This is a single component, no sir. So we could not mention any fits for it. As a general step in GD&T, we said that fits also, the type of fit also between mating parts can be specified.
I'm asking is it a transition fit or a interference fit? Like I understood your point. Like you can just judge whether what type of fit can be coming into this in this to this. I know this is not in the scope, but I'm just asking your view.
For holes, for since we have holes here, for whatever is being fit into the holes, I think it should be an interference fit or transition fit, because that has to be a complete fit for it to be
Yeah. Okay, you can go with that answer next.
The next step, positional tolerance allowed at LMC. Oh,
Okay.
oh, please explain why.
Actually, we had a small confusion here because at MMC condition that the tolerance value, positional tolerance value was given. We thought that it should be taken as a bonus tolerance to calculate the LMC tolerance value, but how to calculate bonus tolerance we were not clear, sir. So what we did was we tried to take the same value of 0.25 mm only and made sure that the component's tolerance level was within the lower limit of the material.
1 second, 1 second. So 9 point. Okay, you just tell me. You tell me the go to the dimensions actually. Yes.
Go to the question.
Question.
Okay. So first we'll see the question.
Yes, sir.
Is it visible? Like so what is the value now? You from the question you will explain me.
From the question, in data May, the hole in data May, it's of size
6.5. Yeah, yeah. So I
9.65
will
to 10 is given.
yeah, yeah, I will tell. So 9.65 is the minimum limit and
Okay.
10 is the maximum limit. Okay.
Maximum.
So when you are considering the maximum material condition, okay, what value you need to assume? Is it 9.65 or 10? Can you answer?
9.65 because that when the hole is of 9.65 diameter, there is more metal to it. So that is the maximum metal condition for the hole.
Okay, okay, good. Okay, so now and when you're going towards LMC, the maximum is 10. Okay, now sorry, when you're going to LMC, the value will be 10. Okay,
Yes.
so now you explain me from 9.65 to 10. Okay, how you are taking this 0.25. 0.25 is the position tolerance, right?
Yes, sir.
Okay, so how you are taking it?
Uh, Sir, actually, I think when we have holes at maximum metal condition, there's also going to be the possibility of a bonus tolerance.
Mhm. Okay, so you go the answer now. I'll just now I got the value.
Show the answer.
Yeah.
Yes, sir.
Okay, I'm clear with the question. Now we can show me the answer. At maximum material condition. Okay, so you have selected the value very good correctly. Next is that okay, it is also accept. Next, go down.
Good.
Oh, the value is 9.75. Okay, so my question is very simple. My question
Mm.
is you have the 0.25 position tolerance at MMC. I'm asking you the position tolerance at LMC. So what will be the position tolerance at LMC? So, but again, you have taken the same 0.25 alone, right?
Yes, sir.
The position tolerance will vary, right? My
Yes, sir.
question is that
We could not crack that exactly, so we took that that as the closest
okay,
value and
okay.
right.
Okay, so now you can tell easily. See, I think you not have understood the question properly. Okay, now I told you the question. What will be the LMC position tolerance? So if it is 0.25 for MMC, you can tell for LMC what is the value.
At MMC, the material, the diameter is 9.65. If 0.25 of position tolerance is present, it could be either the total material would be 9.9 to 9.4, sir, taking
Uh,
0.25 tolerance.
1 second, 9.9 to 9.9 to 9.4. Okay, okay, okay. So I will tell in another way. I will put it in very simple manner. Okay.
Okay, sir.
Uh, so here, if I say 10 value, so no, I'm not considering 10. So I'm taking the 9.65. Okay. So for 9.65, position tolerance is 0.25. Okay, so instead of
Okay.
9.65, if I have the value as 10, okay, if I have the
Okay, sir.
value as 10,
Hmm.
okay, listen this carefully. When I have the value as 10, okay, there is an increase of 0.35. Okay, when I have
Okay.
the value of 10 diameter, what will be the position tolerance? of at LMC. Okay, otherwise I will do one thing. Okay, you explain me. I will explain you answer at the last. Then you can correct it. You explain that in B also.
Okay. Datum B also in
It's
scroll
also
down
similar,
to-
right? It's also
Yes,
similar,
sir.
right?
Yes, sir.
Okay. Okay,
Same
you
way
go
we
with the
did.
second question. You go with the next question. I will see the next question, then I can correct you.
Okay, sir.
Next question is somewhat easy. Go to the next
Kavya,
question.
next question, component 2.
Component 2.
Scroll down.
Yes. Oh, this 1.7. Oh, good. You have taken the same. Very good. LMC, MMC, you have taken correctly. It is 0.288, right? Yeah. Okay. Okay. You explain this one. Now you have to tell the same thing like what I told now.
Yes,
In
sir.
maximum meteor condition it is 0.14. 0.14, right? Can you
Yes,
zoom it?
sir.
Because I 0.14. Slightly zoom it. Oh, okay. No, 0.14. At LMC, what is the value? So which means when it is reaching towards LMC, what will be the value? That's what I question. So hello.
Yes, sir.
What is the value you are going to get at the point? So see, when it is 0.014, is the percent tolerance at 279.279. When it is reaching towards 0.288, okay,
Yes, sir.
what will be the percent tolerance? It should be 1 second. Fine. Okay. Yeah, you saw the result. Final result is okay. 0.293. 0.293 or 203. What is the value?
Kavya, you should
Point
scroll
two
down.
nine three.
293 one second. Getting different value.
Still more down.
293.
Mm. 0.293.
Okay, so okay, let it be this one. Okay, I'm just correcting your small
Yes,
mistake.
sir.
You done analysis was okay, but there is a few correction. I'll just
Yes, sir.
I'm just sharing my screen.
Okay, sir.
You have started like the analysis was okay, good actually. You done the LMC,
Okay, sir.
okay. See, this is the second one. Whether my screen is visible?
Okay.
Hope my screen is visible. Okay, you
No,
see,
sir.
not visible.
No, sir.
I couldn't see.
Maybe Kavya, you should stop sharing so that sir's
Okay.
screen will be visible.
Okay, yes.
Stop share. Oh,
Yes,
yes,
sir.
sir.
Now it's visible.
Yes.
You see here. You see here the question is 0.281 minus 0.02 will become the MMC. That is nothing but 0.279. Okay.
Yes, sir.
And 0.288 is nothing but the maximum material, sorry, least material condition.
Least material condition.
Okay. So
Yes,
my
sir.
question is very simple actually. There is no rocket science. made a very simple question. Even previously also I told you the same simple question only. So
Yes, sir.
when you have LMC, sorry, when you have MMC, the question tolerance is 0.014. Okay.
Okay, sir.
And when you have LMC of 0.288, okay, my question is, what is the position tolerance? This is, I was asking about this value. Okay.
Okay.
I was asking only about this value. Okay. So the simple thing is same in the previous case also I'm asking the same thing. see, one easy method how you can do is, so here they given step by step. Okay,
Yes, sir.
8, 7, 9, 80, 81. So each and
Yes, sir.
everything they given. Okay, up to 9.009 incrementally they given. Okay, so what you can do is you can directly separate also from 288 minus 0.279 you get 0.09. Okay,
Yes, sir.
0.009. Okay, so what you have to do is you have to add this 0.009 here.
Mm.
Okay,
Okay.
when you add
Yes.
0.009, what happens? It becomes 0.023.
0.023.
Okay, so this is
Okay.
what I was also asking in the previous question also.
Yes.
So you understand, right?
Yes, sir. Now we
Yes, sir.
understand.
So you go to now you can tell maybe now you share and you can tell the answer. You just go to the previous one. Go to the previous one.
Yes, sir. Yes. Here.
Yeah. Now it will be easy for you because I don't have an answer for this, but
Yes, sir.
We
I
can
have only answer for that because I have not
0.35,
prepared.
LMC condition is 10 mm and
0.355,
point
0.6.
0.25,
0.25. Okay. So now
0.35,
when I say
point 6.
0.25, it is there is increment of how much? 0.35 into
Increment of 0.35.
0.35. So
so 0.35,
0.6.
0.6. Yeah, this is what I
Yes,
was
sir.
asking.
Yes,
Okay.
Mm,
sir.
okay, sir.
Okay, sir.
Mm.
Similarly, you can go to the bottom, the second one.
Datum
Datum
B.
being
How much you get here?
Point
So it
1.
is
7.8 to 8.2, sir.
okay. Okay. So when I say it's a point, what is the
Point
difference?
4. Point
Point.
4 is the difference.
point.
Point 13 is
Mm.
the tolerance. So it's
So
point
point
53.
five three. Yes.
Oh no. Point four.
Mm.
Point 0.04 or point four.
Point 0.04.
Point four.
Point four.
Point
8.2 minus 1.8 is
point 4.
point four. Okay.
Point four.
So point four plus 0.13.
13.
Point
Okay.
Point five
point
three.
five
Okay.
three.
Okay. This is what I was asking. Okay.
Okay, sir.
Yes.
Go to the last one. So hope you are clear with the first two questions. First two is okay, and the second is also okay. Only small correction needs to be done, and you can show the
Mm.
last one. Last
Answer
is
sheet
about
card.
the GD&T where you can have your own
Mm.
dimensions and the GD&T symbols.
So here we mentioned just few, sir.
Okay. So see, same thing. What you told in the step-by-step approach in the question number 2, same thing you have to apply. So you are told you have to create the 3 to 1 or datum, whatever it is as a first step. And second step, you have to dimension all the things, required thing. Okay. And third one, you have to go to the tolerance, GD&T. So same thing you can apply here, and we will see how I will see how you are done. Okay,
We
you can
have just
explain.
mentioned few dimensions of that. So other datum features, all those. Here we mention the views, and with respect to that, we mention the dimensions. Actually,
Mhm.
the parts of a general connecting assembled connecting rod will be like the cap and the other bearing braces, and here we could see bolts, all those things. So here we have mentioned for the bearing braces and the connecting main part there will be a fit, sir. And here in the finally also we'll be having again another fit with the bearing bush and the connecting rod. So here I have mentioned again one another dimension. And for the bolt and the here there will be one hole to fix the bolt. So I have mentioned its dimension with along with the tolerance and the center distance between these two. Those
Okay.
things I have done, sir. That's all. And in the finally, I mentioned the roughness of the surface as one of the feature for the
Okay.
connecting
So
rod.
what will be the roughness in terms of value? How much you can give surface roughness? So
Actually,
again,
generally,
here you can mention datum A. Sorry, yeah, you can give some datums.
datums. Yes, sir.
Maybe you can see. I can give you some 5 minutes time also. What you can do, you can roughly write the datum A, datum B, or you can show in picture also where you can consider datum A, datum B, and then so here also you need to have the position tolerance, right? So you have the diameter. So you can give the position tolerance, like how we have given the position tolerance in the last
Previous problem.
example.
Mm.
Okay.
Mm.
So similar to that, you have to give the position tolerance here, and again you also have the cylindricity here. So circularity
Yes,
also
sir.
comes into picture here.
Yes, sir.
Again, even the cylindricity also comes here. Okay. And
Yes, sir.
what about
Mm.
the flatness? So if you have the flatness also will come here, right? Flatness and perpendicularity. So when you take,
Yes.
uh, can you explain about that? Well, how it will fit here? Flatness and perpendicularity.
Perpendicular.
See the line.
Perpendicular to.
So
Yes.
you give me the control. I will. So whether my
Arya,
cursor is
give
moving?
control to sir.
How should I give? I have no idea.
Okay, otherwise I myself will take the control. Stop
Yes.
sharing. Oh,
Stop sharing, sir.
no. If you stop sharing, I cannot see it, right?
Yes, sir.
Okay. See, otherwise, see, you have the two lines, right? It is perpendicular to the one more, the left side or right side. To the left side, you can take. Okay, it is perpendicular, right?
Yes.
And it should also be flat when you're taking the slanting rod in the measurement surface table. It should be flat. Okay, so you need to apply the
Yes.
flatness, and again, when you're considering the datum A or datum B, you can go to the previous example what I told. Like the same thing you can apply to some features you can apply here, and again you just check it how you can apply the circularity synchronicity also. That is missing here.
Yes.
You have mentioned the roughness, that is good actually, but it should have mentioned like first you have to give the
Yes, sir.
datum, then you have to.
Datum.
Okay,
Datum.
that is missing here.
Yes,
You
sir.
can
We
correct.
took a lot of time for third question, so we didn't have much time for fourth. We were hurrying,
Okay.
so we missed a lot of information in this, sir.
Okay. Okay.
Question.
Okay. Thank you. It was a really good presentation. Really, first two questions was good, and even the second and third, your approach was really good.
Thank you, sir. Thank you for
Thank you.
clarifying the doubts and giving us the correct answers also, sir.
The last one is again, you have made a very good overview. Actually, center distance is very much important. With respect to dimensional point of view, you made very good actually, and the diameter and everything is okay. And even so, small things that you can correct it, not an issue.
Yes, sir.
Yes.
So, who is the team leader out of the two?
Kavya, sir.
Oh, okay.
Means as mentioned by the essay, sir. There we mentioned as me.
Oh, okay.
Actually, we both work together.
Okay, good. It was really a good presentation, and so maybe I will just ping my mail ID if in case any clarification or anything. Let
Sure,
me know.
sir.
Yes.
I am also planning to give one small seminar on this GD&T.
Okay,
I will
sir.
just get back to all of you through Harish or through the SAE, so that you
Sure,
can
sir.
attend my seminar.
Okay,
Yes, sir. Sure, sir.
So this is my email ID, and you can note down. And if in case any clarification, you can ask
okay,
me.
sir.
Maybe
Okay, sir.
the line you can ask.
Okay, sir.
Yes.
Thank you, sir.
So you are directly coming under Osmania University.
Yes, sir. Yes,
Yes.
Osmania University, sir.
Okay. So Professor Uma Shankar sir, which subject is handling for you?
He teaches thermodynamics and applied thermodynamics, sir, and electives CFD, those he teaches, sir.
What is it? CFD.
CFD, sir, this computational fluid dynamics.
Oh, okay. Even in B itself you have CFD. Good. It's
As an
very tough.
elective, we have, sir.
It's very tough subject. Okay. Good. So in fact, Omar sir and myself had done a lot of programs
Okay.
in through SAE, and also when I came there 2 3 times I came to Hyderabad also for some of the tier 2 events, and
Oh.
even for tier 3 event also I came 2 years
Wow.
back.
Okay.
He's in education committee also, and he's
Yes, sir.
yeah.
For our college also, he is the faculty advisor for our SAE club. We've done so many activities under his suggestions and guidance.
Okay. So you can convey my wish to him. Even I will
Sure,
also
sir, definitely.
I will also when I'm pinging him, I will tell that I will tell him that his student had attended the SA tier 3 event. I'll just inform him.
Yes, sir. Thank you,
Okay.
sir. Sure.
Thanks a lot to both of you. Thanks for the time.
Thank you, sir. Thank
Thank
you
you.
so much.
Thank you, sir.
Welcome. Harish, who is the next presentation?
Next PST, sir.
Yes,
Yeah,
you
they
can.
are in.
Okay. Oh, again they are together. Oh, good.
Good evening, sir.
Good evening. So it becomes like yesterday also you were together, and now also you are together. Good. So now we can start the presentation. So working together is easy, right?
Yes, sir.
Rather than going to the
Better than
phone.
communicating when we're in different homes.
It is like attending the class, attending the seminar in real time, and it's attending the seminar through online. It is the difference like that you are facing. So when you attend the seminar in online, you don't have the personal interaction. But when you are attending the class regular, so you have the direct interaction with the staff. So since you two are together, I feel you are interacting very good. Good. Okay, we will go to the you can present. Maybe I will give you the control. Okay, you already have the control.
Yes, sir. So can we start?
Yes, you go to the first question.
Yes, sir. So actually, we didn't know the method to solve this first sum because for tolerance stack up analysis, we didn't know how to solve for baseline dimensioning. So we just assumed that the tolerance of plus or minus 0.5 will be constant for all the
Okay. Oh,
bases.
can you be slow actually? Can you be slow? I think you are running very fastly.
Okay, sir.
Can you be slow? Yeah.
I'll start from the beginning, sir.
Yeah.
Actually, we didn't know how to solve the first sum, sir, because for solving tolerance stack-up analysis, we didn't know how to solve for baseline dimensionings. So we just assumed that the tolerance of plus or minus 0.5 will be constant for all the dimensions. So we just added the lengths of all the three L1, L2, and L3, and we got the answer of 26, and we just gave the tolerance of plus or minus 0.5. And as far as the second sum,
Where is 6 plus 10 plus? How you arrived at 6? Okay, is L1 minus, okay, L10 16.
yes, sir.
You have taken 16 as
First was 10, and the second length was 16 as a total. So for getting length 1, we subtracted 10 from 16.
Okay, so now you understood, right? You have seen today the answer how you need to approach baseline method. Now you got the answer.
So we don't know if it's right, sir. We didn't get any solution for this sum, sir.
No, you do not get it. Oh my God. Okay, so I thought you would have seen the answers today because we got 1 day extra. I thought you might have got the answers.
We
See,
didn't know. We don't know the answers yet,
okay,
sir.
so here I will tell how to approach.
Yes, sir.
Okay, first you present the second one also. Second one also you present.
Yes, sir. For the second sum, for solving tolerance stack-up analysis, there are two methods. One is worst case method and RMS method. We are more familiar with worst case method, and we use that to solve this sum. According to worst case method, first we need to find out the upper limit for all the dimensions given and add them together. And simultaneously, we need to find out the total tolerance, the lower limit of all the dimensions and add them together. The formula for the tolerance value will be total tolerance of total upper limit minus total lower limit divided by 2. And we got the tolerance value as 1.5. And that 1.5...
Oh, okay. This answer is like quite interesting. Even the last team, they did the same method. They got the correct answer. Oh, it is. But when you go to the previous one, they also approached a similar thing, but they got 26 plus or minus 1. That is what they got at the first one. What value you got for first question? They almost approached a similar thing, but I do not know how they got. Oh, you got 26 point plus or minus 0.5. I think
they just assume that the tolerance doesn't change for any dimension.
Okay. Oh, you assume the constant value. Okay. So yes, I think I do not know how. They also done similar method, but it how they got 26 plus or minus 1. Something. I think that is the value. Something. Okay. So I will tell you the answer how to do. So it's like first one is the baseline method. Okay. So you need to take the baseline one, which means the 10 plus or minus 0.5 is the first point, like is the first area. Okay. And the last area is L3. Okay. So 36 plus or minus 0.5. Okay. So what you have to do here is it is very simple actually. So when you're going for a baseline method or a chain dimensioning method, okay, so you need to close the loop. Okay, which means before you have L1, L2, L3, and before you assume that before L1 let it be 0. Okay, something for name I'm giving 0. Okay, so here to find out the distance between L1 to L3. So I need to close the 0 value, which means 0 is out of my scope. Okay, which means I need to subtract, right or not? So I need to subtract 10 plus or minus 0.5 from the overall length of 36 plus or minus 0.5 between 0 to L3. Okay, so now I need to subtract. You are getting what I'm telling?
Yes, sir.
So 36 plus or minus 0.5 is one dimension. 10 plus or minus 5 is the other dimension. So now I'm going to divide subtract 36 minus 10, it becomes 26. Okay?
Yes, sir.
Right?
Yes, sir.
And what about the 0.5? So the tolerance is 0.5. Okay, so upper limit is 0.5 and even the 0.5. So here, see here, you should not. What you have to do is that you should not directly subtract here. So instead, what you have to do is when you're going for a baseline method, you have to add the tolerance. So 0.5 plus 0.5, how much it comes? It comes as a 1. Okay. So it is like 26 plus or minus 1.
Okay, sir.
You got?
Yes, sir.
Okay, go to the next one, chain dimension. So chain dimension is same thing. So here it is quite easy also for you. So what you have to do is, it is straight direct answer. You have to 6 plus 10 plus 10. How much? 26, right? 6 plus 10 plus 10. How much?
26.
Okay. Plus, I told you need to add the tolerance. Okay. 0.5 plus 0.5 plus 0.5. How much?
1.5.
So 26 plus 1.5 becomes plus, sorry, 26 plus 1.5, right? Yeah. What is the value? It is 27.5.
Yes, sir.
Okay, this is what I told you. how you got this? But anyway, it's your approach is also good. Okay, but even the last team also did the same. This one. Okay.
Okay.
Yes,
So it is like 26. See, you have to go like this. 26 plus or minus 1.5. Okay. 26
Yes,
plus
sir.
or minus 1.5. When you go to the next one, it is similar.
Sir, our answer is also 26 plus or minus 1.5.
Yeah, that's what. It's the correct one.
Okay,
Yes,
sir.
sir.
But when you go to the baseline, you need to correct the same thing. Okay.
Yes, sir.
Basically, you need to close the loop. You need to close the loop.
Okay, sir. Sir, as far as the second one was concerned, second question was concerned, the third question, they have given that in the data made there is a drill of size M5, and we learned that any drill bit above the size of M1.6, they have the tolerance value of G6. So we have selected the tolerance as limits as 0.04 and minus 0.12. Therefore, the LMC will be the least material condition will be at a dimension which is very large. For
Technical features, the LMC will be the largest dimension.
And at MMC,
I think your voice is breaking. 1 second, 1 second. Be slow. I think
0.9.
I'm not. So I think you two are speaking continuously. I think because of that reason, your two voices are coming together. I think. Yeah.
Sorry, sir.
Sorry,
Yeah.
sir.
And I'm not sure whether a signal issue is there at my end. 1 second.
Sir, can I start this question again or?
No. Yeah. You can answer it. No problem.
Okay.
See,
So,
my question is how you have taken that the value of 0.004, like you use some data or something.
yes, sir. We have PhD data book. So
Okay. Oh, okay.
we, for G6 value and 5 mm dia, we got the tolerance values, sir.
Mhm.
And we found the least material condition and maximum material condition.
5 minus 0.02. Okay.
And the question, it is asked to find the positional tolerance of LMC, sir. But
Exactly.
in datum feature, the only positional tolerance for maximum material condition it is given.
Okay.
So at MMC, the positional tolerance will be 0.25 as mentioned in the question.
Okay.
So this at when the dia is 4.988, the positional tolerance will be 0.250. And when diameter increases, the positional tolerance continuously increases along with that. So at the least material
Okay.
condition.
Good. Yeah, I got the answer. It's good.
Yes,
Good approach. Good approach, but it's good that you have gone in depth again. See, you gone in depth. So you consider the value 0.004 from the design data book. Yeah, this is good actually. But it's actually from the question also you can directly, no need of going for this much deep. Directly you got like you had a question with you, or can I open once?
Yes, sir. We have the question, sir.
Can you open? Can you share your question, or can I open? Okay, you can share it. That's very good approach.
we're having it in our mobile, sir. We actually
Okay, no. Otherwise, I will just see. Only thing is that I need to know the answer question. That's it.
okay. So can you share the question, sir? We have the question.
I'm searching the question once.
Okay, sir.
I no need to share actually. I will just see the value because I forgot the values actually. So here it is 0.25 is the position tolerance. Okay, when
Yes,
it is when it is in you also see the question parallelly. So
Yes, sir.
0.25 is the position tolerance when the when the value is in a maximum meteor condition of 9.65. Okay.
Yes,
So when you go from 9.65 to 10, it's almost 0.35 increases there. So 0.35 when you add with 0.25, it becomes 0.6. Okay, but your approach is also good actually. You have taken
sir, that 9.65 to 10, it's actually counter Bohr, sir.
You are right. You are right. You are right. Actually, I have told directly from the things without assuming you can directly take. That's what I also mentioned. I'm not sure whether I given the instruction like this or not.
Actually, we weren't able to find the tolerance from questions, sir. Just with that.
Okay. Yeah, I'm not finding the fault on your answer. I told it's correct. It's correct. Your method is also correct. You have taken the your in fact your method is somewhat perfect also, because in fact it was very much perfect answer. What you given is a perfect one. I agree to that. Okay, you go to the next one.
Yes, sir. And in datum B.
So you're following the same approach here also.
Yes, sir.
So what is the tolerance you have taken here?
So they have given the limit tolerance itself, sir. They have given the the two limit values itself in the dimensioning.
4.25 and 4.45, sir. It's given in the drawing, sir. So
I'm just seeing the drawing.
Yes, sir.
4.25. Oh, they given the value. Same thing they also given there also. In the previous case also they given same thing. 4.25, 4.45. Okay. It's almost 0.2 increases there. Which means from 0.13 you are going to add
Yes, sir.
0.2.
okay, so 0.13 plus 0.2, how much?
0.32.
Oh no, it is 0.3 to 1 second. See, 0.13 when you're adding with 0.2, sorry, 0.02, 0.20. 0.20. Yeah, 0.20 plus 0.13 comes how much? 0.33, right?
Yes,
Yes,
sir.
sir.
So how much you are written?
0.32.
3 to 1.
How come it is coming like that? Okay, there is, I think you have missed something. 1 second.
I think it did calculation mistake, sir.
I am asking for point. You done a very good approach.
Instead of adding 0.1 mm, we have added 0.01 mm, sir. So that's why we went wrong.
0.01 mm. Okay. Okay. So yes. You should have done like that. Exactly.
Yes, sir. But the final answer is almost right. But
yeah, understood. Yeah, I'm looking at only at a step approach only. I'm mostly looking at approach. Even the last team also, I'm looking at approach only. Okay.
Yes, sir.
I know the time my given was very, it was like
we
very
didn't have
tight
time to check all the calculations.
I understood. And again, the question, the way I framed is also slightly, maybe the first question itself, maybe many of you may not have known the target stack up.
Yes,
it is also out of scope, but again, okay. Go to the next question.
So it's the same question, the step-by-step approach of GD&T.
Okay, so you did not answer it?
Yes, sir. We didn't have time, sir.
So we didn't write it down. We just thought
telling during presentation.
Okay, can you quickly tell the answer?
Yes, sir. So first, usually we'll select the surface of.
One second. Maybe you can also see the question. I will also see the question.
Yes, sir. We are seeing, sir.
You see the question? Okay.
Yes, sir. Shall I start, sir?
Yeah.
Yes, sir. For choosing the primary datum, we'll actually choose the side which has more area. That is, we'll choose the flat side, sir, so that it can be placed on the inspection table. So here, the side which is marked as the datum A, that is chosen as the primary datum. and the flatness of 0.1 tolerance is given. And next, we chose the other datum feature, the datum, sir, like B and C, and we give a perpendicularity tolerance for those two surfaces, and then we'll mark the dimensions. That is, initially we'll mark the dimensions without box. Because those dimensions, the tolerances will be given separately in the drawings, like in the title box or somewhere in the notes, and then we'll mark the dimensions with box. That is, for those dimensions, we'll be giving the tolerance separately. And we'll next, for this, the component given in the question, we'll give the circular positional tolerance for the whole, sir, and that position tolerance is with respect to the all three datums A, B, and C.
Okay.
And for all the three surfaces, we'll give profile also, sir.
Where is the profile tolerance given? What is the value, profile tolerance value?
Profile 0.8, sir, with respect to datums A and C.
And there is also one more.
0.8. Yes, I'm seeing the question. I'm not able to find.
Sir, the two sides of the datum A, sir.
Two sides of datum A is 0.8. I could not able to
Yes,
find.
sir.
Ah, yes. Yeah, I can able to find. Yeah.
And this one, it is given in 3D, sir, but usually we'll do the GD&T for 2D drawing, sir. It's just for easy representation. I think they're given in 3D.
Yeah, good. Okay.
Yes, sir.
See, it's basically you need to apply the 3-to-1 principle also here. So can you explain about 3-to-1 principle?
So choosing the datums only, no, sir?
Yes.
Yes, sir. So first, apart from flatness, we'll see like controlling the movement,
Degree of freedom.
Basically, it's based on degrees of freedom, sir. So like if it's the datum A, 3 degrees of freedom will be restricted, and by fixing the datum B, that is secondary datum, another 2 degrees of freedom will be restricted, and by fixing the tertiary datum, that is datum C, the remaining 1 degrees of freedom will be restricted. So it is based on that, sir, choosing the datums.
Okay. Go to the fourth question.
Yes. Sir, for component 2, sir, for third one.
Yes, that is yeah, that one is said to be the fourth question. Yeah. What about the component 2? 0.03. You got the value directly?
Shall I explain, sir, or?
No, I'm just seeing point. See, when you go from 0.79 to 0.279 to 0.288, right? MMC is okay. MMC. Oh my God, how come? Okay, MMC is 0.27. Okay, 0.04. 0.04 when you add to 0.09 is 0.014.
Yeah, 0.023.
What is the value it is given in drawing? 0.014?
It's 0.014.
0.023. Yeah, it's correct. Same approach, yes. Okay, go to the fourth question.
So,
okay, you can explain here.
Yes, sir. Usually we'll choose the surfaces which has more flatness, but in this connecting rod, we didn't find any surface which is perfectly flat. So we took this axis of this bigger side, as datum A, and this surface as datum B.
Okay.
And we have given a perpendicularity tolerance for B with respect to A. Its value is 0.5.
Okay.
And we have chosen this entire axis as datum C. And this datum C and datum A also they should be perpendicular.
Okay,
And
good. Can you tell, can you put it in values like in the form of the GD&T format? Can you put it?
yes, sir. We need to mark, sir.
Just give it, because just I want to understand how because I am also learning from you. It is good that you see. To be frank, first time I'm hearing. See, first time I'm seeing and the participants marking in the Zoom actually, because I attended many meetings. Because I do not know how to mark, how to share, how to write and share to the participants. It's like I'm also learning this new new concept. Okay, good. Uh, you can explain a point. Okay. Okay. Yeah, no need to no need to struggle actually. It's enough. And then okay. What about the flatness? Where it becomes flatness?
So it this surface, but I don't think it will be perfectly flat, sir. So we didn't mention it.
How much can be the flatness value approximately?
0.01.
Yeah, okay. No need right actually. Just I'm asking. Okay. And what about the
And
parallel?
sir, also there will be parallelism, sir, of these two axes. And there will be a circularity for these two circles, sir.
We actually didn't have time for writing all this.
Okay, no, I'm asking like when you take the circularity with respect to what datum you need to take the, like, sorry, with respect to, yeah. See, now you consider a small diameter, or you take the big diameter only, no problem. With respect to the big diameter one, when you take the parallelism, how you normally define?
Actually, here for parallelism, we'll do it based on the axis of the circle, sir. With respect to A, the axis of the smaller circle like should be parallel.
Okay. So when you take the diameter A and diameter C, and the datum comes opposite. So for small diameter, the datum will be with respect, parallelism will be opposite to A.
Yes, sir.
And for the bigger one, the datum will be with respect to C, right?
Sir, can you repeat it, sir?
See, when you are taking the parallelism into aspect, parallelism. Okay?
Yes, sir.
So here, when you define the parallelism, the bigger diameter will be corresponding to datum C.
Okay, sir.
And when, correct or not?
Yes, actually perpendicularity only, no, sir.
What about parallelism? See, okay, that is coming under.
So parallelism.
Parallelism will be with respect to its own datum. Okay, it will be with respect to A and with respect to C. Yeah, you are right. And what about the circularity or the cylindricity? Can you tell for this?
Actually, we don't need any datum for circularity, sir.
Okay.
So we'll just mention the circularity symbol along with this respective tolerance.
Exactly. What can be the tolerance for circularity? It can be 0.0. Okay.
0.05.
Okay, that is up to even you can use the Christian data book. Okay. What about the cylindricity?
No, sir. Here there won't be any.
But because both are cylinder, right? See, it's completely, when it comes to the circularity, it's also, you can mention it is like, see,
But it will be like very small, no, sir, like negligible.
negligible, but again, the problem is, see, this connecting rod is one end connected to the piston pin and another is connected to the crankshaft. So it is again both reciprocation and also the rotary motion. Two motions are also going to happen, which means the whole what you are telling, it can undergo radial expansion or contraction and even the axial. means all the two sides are possible, or four sides also possible. So considering that, to some extent it will be good if you give the simplicity also, but again, as you said, it will be very negligible. But again, to meet that again, because the problem is the manufacturer. When you're considering the manufacturing aspect, no manufacturer will be perfect to give the exact value with respect to the diameter. So they will ask some tolerance with respect to the simplicity, and even they will ask some tolerance with respect to. They also ask some they want some deviation. So if they want to meet the correct dimensions or the without deviation, then the cost to manufacture the particular part is going to be higher. So in some cases they also ask simplicity, but it's again very difficult for the manufacturer to manufacture with the exact dimension what had been given by the company. So in that case, it may be applicable. Got what I told? Hello?
Sir?
You got what I told?
Sir? Yes, sir. Hello, sir.
Yes.
Yes, sir. We got the concept, sir.
Okay. It is basically the honing kind of thing. Basically, you also do some honing.
Yes, sir.
Honing operation where you have some close to 30 micron tolerance, and considering that this is very much important. Even the concentricity also comes into picture here. But again, I don't want to go in depth again. It's like just I want to understand how you are approaching it.
Yes, okay.
I think you have answered all the questions.
Yes, sir.
Okay, thank you, and thanks a lot. It was a really a nice presentation.
Thank you, sir.
Thanks for your time.
Thank you for your time, sir.
Thanks for my time also. Thank you. Okay.
Yes, sir.
Maybe you can contact me if in case any doubt. You can note. I think my you can see the chat box, right?
Yes, sir.
You can see my email ID. Okay. So again,
Yes, sir.
you can note down, and you can contact me in case anything. So you are from PhD college or PhD high tech? You have two colleges, right?
Yes, sir. PhD Tech.
High tech. Okay, it is parallel group. Okay, because there is Professor Taylor, madam, in PhD. I know her, and I know Rutramurthy is a former principal of PhD, and then some Natarajan, Professor Natarajan. I know a few people in PhD, but I am new to your college actually. I do not I don't directly. I did not come to your college, but PhD I have come to many times. Almost 4-5 times I came. Okay. Thank you. Thanks for your time.
Thank you, sir.
Yeah.
Can we leave, sir?
What? Can you repeat?
Can we leave the meeting, sir?
Yes. Yes.
Yes.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you. Welcome.